I know you all hate word problems, but I think a lot of it might be that you just think you're going to be bad at them before you even begin them. And if you just kind of approach them more like, I think I can do this, then you might have a lot better of a time. Now, that sounds kind of cliche, but it's really true. Your mindset can really help you when you're doing math. If you think that you're bad at math, you probably will be. If you think that you can accomplish math, then maybe you can do a little bit better. So today we're talking about inverse and joint variation. And you've probably seen this equation, rate times time is equal to distance. But I can write this in two different ways, where time is equal to distance over rate, or rate is equal to distance over time. So imagine that you have a constant distance, and you have two people kind of running a race, right? And here's this guy, he's really fast, so he's running fast this distance, right? He has a really high speed. And then there's this other guy, he's a little bit chunky, and he is running a little bit slower, right? So he has a smaller speed. Now let's think about who has the higher time. So the first guy runs the race, and he has a really fast rate, right? He's running fast. He might be running like 9 miles per hour. So he beats the other guy. In other words, he has a really short time. So when he has a high rate, he has a short time. It doesn't take him long to run the race. Whereas the fat guy, right, he's running very slow, maybe only 4 miles per hour. And so it actually takes him a long time to finish the race, right? His time is longer, even though his rate was smaller. Okay, so this is called what we call inverse variation. So if we have y varies inversely as x, this equation would not be what we saw before, where it's y equals kx. It would actually be y is equal to k, that constant, over x. So that if I have x going up, it's actually not going to make y go up. It's going to make y go down. That's exactly what we saw with the rate and time. When rate went up, time went down. Imagine you have like 1 over 100. That's a really small number, right? So the bigger x is, the smaller your actual number is going to be because it's on the bottom of that fraction. Okay, let's go ahead and go over some word problems, and I'm going to show you a way to approach this word problem that I'd like you to start trying. So the first thing I'm going to do is I'm going to kind of decide whether a picture is relevant in this case. Now here we're just talking about current in a wire, and so a picture really isn't super relevant, so I'm just going to kind of write out my givens as a second step. Now, my current, which I'm going to use I, you could have used C, that would be okay, because that actually does make more sense, although the actual proper letter is I. So I is equal to 5 amps, and my resistance is equal to 24 ohms. So my second current is equal to 8 amps. Now I'm going to write what I'm trying to find. Okay, what I'm trying to find is what my second resistance is when my current is 8 amps, right? That's what I'm looking for. Okay, now the third thing we're going to do is we're going to find an equation. Now I'm going to look at this sentence, and I see that the current in the wire is inversely proportional to resistance in the wire. So I'm always going to write I, right, that's the first thing, the current, is equal to K. And then I'm going to figure out the rest of it, right? I have that constant of proportion. Well, since they're inversely proportional, it's going to be I is equal to K over R, not K times R, that would be direct variation, but I is equal to K over R. Okay, so I'm going to use my first two givens. My first two givens is that I have a current of 5 amps and a resistance of 24. Okay, so then my K, once I solve for it, is 120 amps times ohms, right? And that's my K. So now I can use that K to solve for the second case, right? I have a current of 8 amps, and I'm going to figure out that R, right? So 8R is going to be equal to 120, and once I figure out what R is by dividing by 8, I get R is equal to 15 ohms. Now imagine this, like the more resistance there is, then the less a current can flow, right? The less resistance is, the more current can flow. And that makes a lot of sense to us logically, right? It's kind of like when you squeeze a hose and you kind of leave it so that there's not really much room, then only a little bit of water can flow through. The harder you squeeze, the less water flows through. The less you squeeze, the more water flows through. So those things are inversely proportional. One goes up while the other one goes down. So now we're going to talk about joint variation. And joint variation basically says y varies jointly as x and z. So the equation we're going to make is y equals k times x times z. So it's kind of like direct variation, but like two different things. So we're going to multiply them all together. So let's take a look at this. Conductance of a wire varies directly as the square of the wire's diameter, inversely as the length. Okay, a picture is not super relevant, so let's go ahead and write out our givens. So first of all, the length, right? It's 50 meters of wire, which is a length. The diameter, they tell us, is 2 millimeters, okay? And I'm going to call my length just L, okay, for short. and I'm going to use D for short for the diameter. And the conductance, which I'm going to use C, is 0.12 MHO, which is the backwards ohm, and that's how they came up with that unit, because resistance is in ohms. Anyway, so we want to find C when the length is 75 meters and the conductance is, and the diameter is 2.5 meters. What is the conductance? Okay, so now I need to make an equation. So my conductance is going to be equal to K. I always write a K, right, when I'm doing variation problems. Now it's varying directly as the square of the diameter, so I write D squared on the top, and inversely as the length, so I'm going to write L on the bottom, right? So whatever's inverse is going to go on the bottom of the fraction. Whatever is direct proportion or joint variation is going to go on the top. Okay, so I'm going to plug in my first set of knowns. I know that the conductance is 0.12. I know that my diameter is 2 millimeters. I'm going to square that. And then I know that my length is 50 meters. So I'm going to figure out what my K is from all this information. Okay, so here I have 0.12 ohms. I'm going to multiply by 50 meters, and then I'm going to divide by 2 millimeters squared, which ends up being 4 millimeters squared, right? And then I figure out what this is by just plugging all this into my calculator, 0.12 times 50 divided by 4, and I end up figuring out that this is going to be 1.5 MHO. Okay, so this is, and it's not MHO, sorry, it's MHO times a meter divided by a millimeter squared. Your K's are always going to be like super weird units. Don't worry about it too much, right? It just means that it's going to kind of cancel out all the other units once you plug it back into the equation. So now I'm finding C when the length is 75 and the diameter is 2.5. So I plug those things with K back into the equation now that I've found K. And I figure out that I have a conductance of 0.125 MHO. So imagine I have an ideal gas, you'll learn about this in chemistry, and the volume of a given mass of gas varies directly as the absolute temperature and inversely as the pressure. Okay, imagine you take a balloon and I squeeze this balloon, so I add a bunch of pressure. The balloon is obviously going to get smaller, right? We can kind of imagine that, right? And same thing, we talked about temperature, right? Whenever I increase the temperature, all the molecules get super excited and they're flying around and they're hitting the sides, right? And it starts to expand the balloon. Okay, so we're given a couple things. We're given that at a temperature of 2 degrees Celsius, 99 pascals, or kilopascals, sorry, 4 grams of helium will occupy 23.1 liters. So our temperature is 2 degrees, and that's equal to 275 Kelvin, right? We have to add 273 in order to figure out the Kelvin, because we always want to work in the absolute scale. Now, the pressure is equal to 99 kilopascals. You'll start to recognize certain pressure units, pascals, and ATMs and things like that. And the volume is 23.1 liters. Now, I've also written that the mass is 4 grams. That's not really going to come into our calculations, but we're going to write it anyway, just because it's a given in the problem, right? A given number. We're just writing every number that they give us. So the second temperature is 27 degrees Celsius, which is the same thing as 300 Kelvin. And they give us a pressure of 121 kilopascals. So the pressure has gone up, but the temperature has also gone up. So now we're going to find the second volume, right? So the temperature going up is going to make the volume expand, but the pressure going up is going to make the volume shrink. Okay, so the volume of a given mass varies directly as the temperature, so I put the temperature on top, and inversely as the pressure, so I put the pressure on the bottom. And I always, always, always have K when I'm having a direct, any kind of variation problem, direct or inverse or joint. I always have a K. So always just write that first. Right, volume varies, and then it's V equals K, and then times whatever else. Okay, so here I'm going to plug in all of my knowns to figure out what K is. So 23.1 equals K times 275 divided by 99. I just rearrange the equation to solve for K and end up getting that K is equal to 8.316, which I know that is, if I know anything about chemistry and if I've done any ideal gas, that's actually like a real number, a real constant that has been found by scientists. So I know that I'm on the right track with this problem, which is good. So then I'm going to plug that K that I found in with the second two givens, right? The pressure 2, the temperature 2, and I figure out that I have a volume of 20.6 liters. Okay, good luck on your homework. Write out those givens, write out those two finds, find your equation, and don't be so stressed about word problems.